Your app is running like a dream on your laptop. You're feeling good. You send it over to your teammate, or maybe you push it to a server and bam, it just completely falls apart. Sound familiar? Yeah, that's the classic, incredibly frustrating, it works on my machine problem. And for the longest time, that was just part of the deal, a painful reality of shipping software. But what if you could guarantee that if your code works for you, it works exactly the same for everyone, everywhere? Well, turns out you can. And that solution is Docker. At its heart, Docker is all about packaging your application, and I mean everything, all its libraries, its settings, the whole shebang, into this neat little package called a container. Think of it as a perfectly self-contained little bubble where your app can live. So how does it start? With a simple text file called a Docker file. Seriously, the best way to think about this is like a recipe for a cake. It's just a list of instructions. Start with a basic operating system, then install this software, copy my code over, and finally run this command to start. And when you follow that recipe, what do you get? You get an image. The image is the baked cake. It's the final, read-only blueprint of your application with all the ingredients perfectly mixed in and ready to go. And that brings us to the final piece of the puzzle, the container. A container is simply your image brought to life. It's a running instance of that blueprint. You can spin up 1, 2, or 100 containers from that single image, and every single one will be an identical, isolated, perfect copy of your app. Okay, so that's the what. But the real question is, why should you care? Why has this one idea completely transformed the entire software industry? Let's get into the real-world benefits. I mean, the benefits are just massive. First, you get that 100% consistent behavior no matter where it runs. They start up in seconds, way faster than old-school virtual machines. They're also incredibly lightweight, so they don't hog your system's resources. All this makes working in teams and automating things so much easier. And this quote right here, it just hits the nail on the head. Deploying software used to be this complex, error-prone mess. But once you switch to containers, that whole class of problems tied to different environments, they just vanish. It's amazing. And hey, don't just take my word for it. We're talking about the biggest names in the game. Netflix, Spotify, Amazon, Google. They all rely on container technology every single day to run the massive apps that we all use. This stuff is battle-tested at a ridiculous scale. So you're probably wondering, how does Docker pull this off? How is it so fast and lightweight? Well, it all comes down to some really clever tricks it plays with the computer's operating system. The real magic here is how it's not like a traditional virtual machine, or VM. A VM has to boot up an entire guest operating system on top of your main one, which is super slow and heavy. Docker containers, they skip all that. They share the host machine's core, its kernel, and just use clever isolation features to keep everything separate. That direct access is what makes them so blazing fast. Okay, theory is cool and all, but where does the rubber meet the road? Let's talk real-world uses, because there are a ton. Let's say you need a database for your project, like Postgres. Instead of going through a messy installation on your laptop, you just run one command, Docker run Postgres. And boom, you have a clean, isolated database ready in seconds. It's that easy. And then you've got microservices. Docker is literally the backbone of this entire architectural style. For a big app like an online store, the login system can be one container, the payment processor another, and so on. This means you can update one part without any risk of breaking another. It's a lifesaver. This is also an absolute game changer for DevOps. When you're automating your code testing and deployment, you need a perfectly clean slate every single time. Docker provides that, ensuring your tests are always consistent and reliable. No more, well, it passed on my machine excuses. Okay, so this all sounds great, but is it hard to get started? Not at all. The whole workflow really boils down to 4 simple steps. First, you write your recipe, the Docker file. Then you use Docker build to create your image. After that, you use Docker run to bring it to life as a container. And finally, you can push that image up to a registry to be deployed literally anywhere. All right, we've gone through a ton of info pretty quickly, so let's boil it all down to the absolute most important things you need to walk away with. So on the one hand, the advantages are just undeniable. It's fast, it's lightweight, it's consistent, and it makes deployment a breeze. But, and this is important, you have to remember its key limitation.
Because containers share the host's OS kernel, they aren't as deeply isolated as a full virtual machine. It's a trade-off and something to keep in mind for super high security situations.
Look, if you walk away with just one thing from all this, let it be this. Docker lets you package your apps and run them anywhere. It's the ultimate fix for the "it works on my machine" problem, and it makes the entire process fast, consistent, and super reliable.
We've really just scratched the surface here. There's so much more to explore, from networking to managing data to orchestrating thousands of containers with tools like Kubernetes. If you want a deeper dive, let me know in the comments below, and don't forget to subscribe. Thanks so much for hanging out with me.